Now, up to this point, we've had some opportunity to see 3 different first hop redundancy protocols: VRRP, HSRP, and gateway load balancing protocol. And so it's time now to take those skills that we've learned and apply those to a production network. So we get a phone call from Bob. Hey, Bob, what's up? Yeah, we're in. I'll tell him. Okay, well, thanks. We'll see you in about a half hour. Awesome. So Bob has called us and asked us if you and I would like to help design and implement some fault tolerance for people's default gateway, including people on VLAN 10 in the production network. So let's go to Bob's office. We'll take a look at the topology. We'll come up with a plan, and then we'll do some hands-on lab to implement that plan. So we walk into Bob's office, and he shows us this diagram here of the Arizona topology, and we confirm with him, now you want us to help provide fault tolerance for the default gateway that clients are using. And he says, yes, absolutely yes. So let's start off by taking a look at who we're serving here. So we have this VLAN, VLAN 10, and we have a bunch of users in that VLAN. And for VLAN 10, the IP address assignment we have there is 10.16.0.0 with a 24-bit mask. And currently, for VLAN 10, we have these 2 multi-layer switches. Here on the top is Core 1. And any guesses about this one right here? Yeah, Core 2. Awesome. So Core 1 and Core 2 both have, these are both multi-layer switches. They have layer 3 switched virtual interfaces inside of VLAN 10. So they both have an interface VLAN 10, and their IP addresses, respectively, for their VLAN 10 interface is 10.16.0.1 for Core 1 and 10.16.0.2 for Core 2, both with a 24-bit mask. So we can just imagine one of those computers off of this access layer switch. Maybe this PC is 10.16.0. And we'll give it the last octet of 10. Great, slash 24. And for the default gateway, instead of pointing to .1 or .2, we can set up a third IP address to be used for fault tolerance purposes to be supported by hot standby router protocol. So the virtual address that we're going to add is 10.16.0.3. So what we would do is we would go to each of these VLAN 10 interfaces and use the commands to enable hot standby router protocol, including this virtual IP address. And then we want to train the clients on that VLAN 10 that for their default gateway, they should use .3 as their default gateway. And then between Core 1 and Core 2, with the hot standby router protocol, they would provide that fault tolerance for that virtual IP address. Now there's one other element that I would like to do in this lab as we apply this, and that is I don't want to use the standard layer 2 address. So normally when we support an address like 10.16.0.3, behind the scenes there's a virtualized layer 2 address as well. So the router that's active for this IP address also supports that corresponding layer 2 address. We can actually tell hot standby router protocol to actually use the layer 2 address that's already associated, the burned in address that's associated with the existing interface. So in the lab, what I'd like to do is also implement that command, and I'll walk you through that when we get to the interfaces for VLAN 10 on Core 1 and Core 2. So let's jump in the lab. We're going to use our admin computer, which is DC-NUG. We'll launch MT-PuTTY, and we'll open up consoles to Core 1 and Core 2. So here we are at DC-NUG, and I've got MT-PuTTY open, and I've got a tab open for Core 1 and Core 2. If you need to open a tab, you just click on the servers and grab the device you need and open a tab, and away you go. All right, let's start on Core 1. And one of the things we might want to do to start off with is find out what interfaces are up and their IP addresses before we start configuring. That way we can verify we're on the right interface to begin with. So we'll do a show IP interface brief. And because it's a multi-layer switch, we have lots of output here. We could thin this by doing the same command, up arrow key, space, a pipe symbol, and then space, and then we'll just do an exclude. So exclude says, okay, I'll show you everything from the normal output except for any lines that have what you're about to exclude. So if we want to exclude any lines that have the word unassigned, because we don't want to see that in the output, we can just put a few characters of unassigned, press enter, and it will just surgically remove that from the output. So here is the interface that we are going to focus on, the VLAN 10 layer 3 interface. It's up, it has the IP address of 10.16.0. Fantastic. That's where we're going to add the configuration on that interface for HSRP. So we'll go into configuration mode. We'll go to interface config for VLAN 10. And then here, we'll go ahead and do the standby command. Give it a question mark. Let's go ahead and specify use BIA for used burned in address. And then let's implement standby for group 10. And we can use a number here. If you want to use the same number as the VLAN, That's really handy, so we'll do that. So we'll use group 10 and then specify the IP address being supported is 10.16.0.3 and press enter. And it says, Keith, you forgot the D. All right, I can fix that. So we'll go ahead and add the D. Boom, there we go. Now we can do a do show standby. Press enter. So at the moment, it's going through a few states to identify whether or not there's other speakers out there and if it should be the active router for that group. And here in a moment, there it is. We should have the message indicating we are now the active router. So now we'll just do pretty much the same commands in VLAN 10 interface over on Core 2. So let's go over to Core 2. We'll go into configuration mode. Let's do a do show IP interface brief. We'll exclude anything that has the word unassigned in it. And there's our VLAN 10 interface. Great. So we'll go into interface VLAN 10. And we'll type in standby. And we'll go ahead and say use burned in address. And then standby group 10 IP 10.16.0.3. Boom. And we are done. So we can let that cook in the background. We already confirmed that Core 1 is the active router. So let's go to our client PC and change the default gateway to point to that new virtual IP address for HSRP, which is .3. So here in the lab, we'll go ahead and log on to our client PC. And let's configure the network interface. On this version of Windows 10, you can right-click on the Windows icon, bottom left-hand corner, and then there's a menu option right here for network connections. That's one quick way to get there. And then we can right-click on the network 1016, and then from the drop-down, select Properties, and then double-click on the Internet Protocol version 4 to change its properties, and we're going to change the default gateway to .3. And then we'll click on OK. And OK again, and let's bring up a command prompt. So we can right-click on the Windows icon, bottom left-hand corner, bring up a command prompt that way. Then we'll type ipconfig, just to confirm that our default gateway is 10.16.0.3, and also let's verify that we can ping it, 10.16.0.3. So whoever the active router is for HSRP is responding to us at the moment. Fantastic. Also, if we did an ARP-A to look at the ARP cache, we can see something pretty cool here, and that is that for the layer 3 addresses of .1 and .3, so if we did a ping to something behind Core 1 and Core 2, and if we take a look at our topology, over here on this network, we've got 10.16.6.5. That is the IP address on R1 here. So we can use that as a target. So we can ping from our PC, which should go through our default gateway, which is .3, being supported by Core 1, and then being routed over here to R1, who's our destination for that ping. So the key here is let's use this as our target for testing. So we'll do a ping of 10.16.6.5, and that works. That's great. And let's also do a trace. And here's how we spell trace in Windows. It's TRACERT space -D for don't bother doing name resolution, and then the IP address that we're tracing to, 10.16.6.5, and that's going to show us the path. So it went through Core 1 at 10.16.0.1. That was the actual router that moved it for us. And then it hit R1 at .5. Perfect. So now as a test of our fault tolerance, though, let's go back to Core 1. And we'll take that VLAN 10 interface, which is currently active for the HSRP group, and we'll just disable it completely. And then we'll watch and see whether or not Core 2 and its VLAN 10 interface takes over as the active router for the HSRP group, which it should. Let's check it out. So up here on our admin computer, logged on to Core 1, I'll make sure we're inside of VLAN 10 interface configuration mode. And let's go ahead and do a shutdown and press enter. And that's going to take out that interface, any relationships that that interface may have been maintaining with other devices, with OSPF or other protocols. And it's also going to take out the HSRP service that it used to be active for. So we can see that right here. The HSRP change, it went from active to something less than active, meaning it's not doing the job anymore. And if we go over to Core 2, we have a console message here indicating that it is now the active router for the HSRP group. So if we go back to the client PC, we should be able to go ahead and do a ping to that same address. That works. We should be able to do a trace route, and we'll just use some up and down arrow keys to get there. We'll do the trace route, but this time, the first hop, check it out. The first hop is 10.16.0.2. Because the Core 2 multi-layer switch is now the active router on its VLAN 10 interface supporting the customers. So in this case study, we've taken our knowledge and skills regarding setting up or configuring some first hop redundancy protocols, and we've applied it to our mock CCNA production network. So if you've completed this, whether it's here in the virtual labs or have done it on your own gear or in another virtual environment, please give yourself 10 more points as we build towards 100, gaining skills along the way. I've had a lot of fun, and I look forward to seeing you in the very next video. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.